So this GATE 2007 question, 2 marks question reads that data forwarding techniques can be used to speed up the operation in presence of data dependencies. Consider the following replacement of LHS with RHS. There are 4 options and they're asking in which of the following options will the result of executing RHS be the same as executing LHS irrespective of the instructions that follow. So to completely understand this question, you need to know about two terms, that is data forwarding as well as data dependency. What is data dependency? For example, in this first option, register R1's value is being written into some memory location, and from that very memory location, we are again reading the value and copying it into register R2. Here you can see we have this data dependency. That means the value which is being written by first instruction is being used or read by the second instruction. So if we see these two lines from pipelining point of view, you'll realize that they cannot be executed in parallel, because only when value in location LOC is updated by the first instruction, only after that point the second instruction can start reading. So this is data dependency. That means this data is the data that is written by the first instruction is being used by the second instruction. So here we have a dependency, here also we have a dependency. Anyways, we'll analyze the options given in question. First we will just understand the second term, which is data forwarding. So data forwarding means if we try to forward data here, first what is happening? R1's value is first being given into location, then R1's value, now this location contains the same value that R1 contained, that very value is also being copied into R2. So what's a better solution to run these two lines in parallel? What we can do is simply just bypass copying into memory. What I mean is simply just copy R1's data into R2. So that way we can run these two lines in parallel. Now you might ask, what happens to the memory location? When do we update it? We can also update it in next line, because now there is no data dependency. R1's value is being read here and it's written into R2. Then R1's value is again being read here and it's written into location. Here we have eliminated the data dependency by changing this code into this code. Now if you need to learn more about these things, data dependencies, data forwarding, please watch my pipelining videos. I've explained this in very detail. Anyways, let's try to attempt this question now. So we need to replace LHS by RHS. First of all, in option A, so what's the question? Let's see. The question reads, in which of the following options will the result of executing RHS be same as executing LHS irrespective of the instructions that follow? So let's see the first option. First of all, R1's value is being copied into LOC, and that very same value is also being copied into R2. That means we can write like this. Okay. And RHS is R1's value is going into R2. That's okay. R1's value is going into location. That's okay. So this option is correct. Okay. Now second option is R1's value is being copied into location and location's value is being copied into R2. This part is same. Let's see what is RHS. RHS says R1's value is being copied into R2. That's okay. But who is going to update the memory location? Here we have missed LOC. No, because in this LHS, Memory location is also being updated, but on RHS we haven't done that, so this option is wrong. Then let's see the third one. R1's value is being copied into location, then R2's value is being copied into location. On RHS we are writing R1's value is copied into location. This one is wrong, because say R1 contains 3, R2 contains 7. First of all, we are copying R1's value into location and say this one is the memory location, LOC. First we are copying R1's value, that means 3. Then we are copying R2's value. So 3 now gets updated to 7. This is what this LHS is doing. And on RHS, we are writing only R1's value is copied into location. That means first step is done. This one is done. But final effect of executing these two lines is R2's value must be present in location, and final effect of executing this is R1's value is present in the memory location. So this is incorrect. That means this option won't work, because we need R2's value in memory location at the end of executing either this or this. Anyways, let's see the fourth one. Yeah, this is correct, because here the final value in memory location is same as R2's value. Either you execute this or you execute this, because anyways R1's value after going into memory is being overwritten by R2's value. So just simply write R2's value only, like we are doing here. Why to first copy R1's value, then overwrite it by R2's value? Okay, so the option is 1 and 4.